Hi, this video is regarding irrational numbers. For the ninth grade students, irrational numbers are very new. What is irrational numbers? The irrational numbers are the part of real numbers. Real number is divided into two parts, rational and irrational numbers. All the integers, whole numbers, natural numbers are coming under rational numbers. Irrational numbers. What are irrational numbers? Irrational numbers are mainly decimals. So can we say all decimals are irrational? No, we cannot say all decimals are irrational. Decimals will come in rational numbers also, because 5.2, it is a decimal number, but we can represent it as 52 by 10 in P by Q format. That means it is a rational number. So what will come under irrational number? We will use two terms: non-recurring, non-ending decimals. Non-recurring means non-repeating, means 3.14159 etc. This is the value of the pi. We know pi. Pi is the ratio of the circumference of a circle to its diameter. So value of pi is, normally we take it as 3.14 or 22 by 7, but its value is 3.141592, and that is non-recurring. Means what is recurring? Recurring decimal 6.333 is recurring. Normally we will represent it as a hyphen above the reoccurring number. Recurring means reoccurring number several times. So this 6.3 is recurring decimal. Recurring decimals are not irrational number. Irrational numbers are numbers like this, non-ending. There is no end for the result, and non-recurring. There is no pattern repeating in the decimal portion. This type of numbers are called irrational numbers. So pi is irrational number 3.141592. And what all will come in our day-to-day life? Irrational numbers. What is square root of 1? We know 1 itself. Square root of 4, we can easily say 2. Square root of 3, we cannot easily say square root of 3, because square root of 3 is irrational. Square root of 3 is 1.7320 etc. And square root 2 is 1.414 etc. etc. So we understood that square root of a perfect square is a rational number. Just like root 4 is 2, root 9 is 3, root 16 is 4. But the square root of a imperfect square, just like 2, 3, 5, 7, 10, any number, any imperfect square is, square root of any imperfect square is irrational number, and it have a decimal. In the decimal part, it will go endlessly, non-recurring. This type of numbers are called, this type of numbers we cannot represent in the form of P by Q. So you will be having a doubt that if it is recurring decimal, then it is also, is it irrational or rational? It is rational, no doubt, because we can represent it as P by Q form. That will come later in this chapter itself. But non-recurring numbers, like we don't have any pattern like that numbers, we cannot represent in the form of P by Q. That type of numbers are called irrational. So regarding the pi, we know what is pi. Circumference C of any circle divided by its diameter is known as pi. Ratio of the circumference to its diameter is known as pi. Pi normally we say 3.14. Normally we don't put any dots here because we take the value as it is, or 22 by 7. So somebody will be having a doubt like that. It can be represented in P by Q form. Still, why it is irrational? For that, I drew a circle and I measured the circumference with a thread. Put a thread on it and measured the length of it, and I got the circumference as 5 centimeter. Anything. So we cannot measure the circumference with the formula 2 pi r because we are finding the value of pi, so we cannot use the formula. So manually we measured the circumference and the diameter also. With center we measured with the scale, that is 1.56 centimeter, something like that. So this 22 by 7 pi is equal to C by D, that is 5 by D. We are getting any other number. No, 3.41467, etc, etc, etc. Why this is like irrational? Because this C we measured with the thread, I got 5, but 5 may be 5.1 or 5.16 or 5.165 and up to different decimal levels it may be having value. So C we cannot say is rational. C itself is irrational. We are measuring with any scale or compass or whatever it is irrational. D is also irrational. So the quotient of two irrational numbers is perfectly irrational. That is why pi become irrational. So we know that all we learned in previous section is that all real numbers can be represented in a number line. So irrational numbers also real numbers. In next session we will discuss about how we will represent root 2 and root 3, root 5 extra are on the number line. Compass and scale is needed. We will discuss it in detail later.